This is AQA, GCSE Higher, paper 2, and it's June 21. Okay, so it's June 21, paper 2, Higher, AQA. That's partly for my reference, as well as anybody else's. Right, number 1. Circle the factor of x squared minus 5x. So we'll factorise this, and an x comes outside the bracket, and it's x minus 5. So the one that's the factor is x minus 5. The other factor is x, but that's not there. A is a half of b. Work out the ratio of a to b. 1 to 2. Okay. If it's like 10 to 20. 1 to 2. Well, a is half of b. Right, the first 3 terms of a geometric progression are 2/3, 4/9, 8/27. Circle the fourth. So on the top, we're multiplying by 2. So the next one is going to be times 2. And on the bottom, we're timesing by 3. So the next one is times 3. So it's going to be 16 over 81. Circle the reason why these triangles are congruent. Congruent means exactly the same lengths of sides and exactly the same angles. So we've got a 9 followed by a 5 followed by an 8. Going around like this one, it's got a 9 followed by a 5 followed by an 8. Okay, you don't need to worry about that directional, but so it's side, side, side. A is for angle, S is for side. Okay, solve 10x is 62.4 minus 3x. So if we add 3x to each side, we get 13x is 62.4. Okay, and then we divide both sides by 13, and we do it on the calculator. 62.4 divided by 13 is 4.8. Okay, I'm going to do a quick check. 10 times 4.8 is 48, so I need to see if this is 48. 62.4 minus 3 times 4.8 is 48. Lines A, B, C, D, E intersect as shown. So we've got an A, B, C, D, E. A and B are parallel. Notice they're marked with the arrowheads. The other ones are just lines. Work out the size of angle X. Okay. Oh. Okay, so in here, that's the 52 degrees. I'm just going to get as close as I can to X, home in on it. So when you've got straight lines that cross, opposite angles are equal. Okay. Now on this one here, this angle and this angle add up to 180. So that one is 70 degrees. And similarly for this one, 49 plus this angle add up to 180 because they're on a straight line. So that's going to be 131 degrees. Okay, well, let's just put, I think it's called diagonally opposite. Rule is diagonally opposite angles for the 52 degrees. 180 take away 110 degrees. 180 is 70 degrees. That's the second one I did. 180 degrees take away 49 degrees. 131 degrees. Now inside a four-sided quadrilateral, these add up to 360. So we've got 52 degrees plus 70 degrees plus 131 degrees. I'll do that on the calculator for the quick speed of time. 52 plus 70 plus 131 is 253 degrees. So that means that angle there, 360 degrees, take away 253 degrees, 107 degrees. So eventually we get to X now. If that's 107, X is 180. But these two have to add up to 180. Take away 107 degrees, which is 73 degrees. Number 7. 102 boys and 85 girls took a test. The table shows information about the mean marks. The pass mark for the test was 70. Was the mean mark for all these students greater than the pass mark? You must show your working. Okay, so what we can do, we can work out if we've got 102 boys with a mean of 68.4, we can say the total marks for, we'll do the boys first of all, is 102 times 68.5. This is because when you add up all their scores and divide by 102, you get 68.5. So if we don't divide by 102, we'll get the total of the scores, and it's 102 times 68.5. 2 times 68.5, 6987. And then for the girls is 85 times 72.4. Doing that in the calculator, 6154. So the total for boys and girls combined is 6987 plus 6154, which is 11, 14, 11, 13. And the mean is therefore 13141 divided by 102 plus 85. Okay. Just check that. I've checked that on the calculator because I had some of it on the screen already, that bit. So it's 13141 divided by, open bracket, 102 plus 85 is 70.3 to 1 dp. So the mean mark is greater than 70. The pass mark is 70. So the pass mark 70. Okay. Describe fully the single transformation that maps ABC onto ADD. Right, this is actually an enlargement, even though if you think about it, we've got ABC, the large one, mapping onto the small one. But we say it's the scale factor because it goes from, look, the base there is 1 because it's half there and half there. The base there is 4, so it's scale factor 1/4, and the centre of enlargement is going to be A. Centre of enlargement, which is 3, 9. Okay. Number 9, a ball contains 5,000 cubic centimetres of air. More air is pumped in at a rate of 160 cubic centimetres per second. The ball is full of air when it becomes a sphere with radius 15 centimetres. The volume of a sphere is 4/3 pi r cubed, where r is the radius. Does it take less than a minute to fill the ball? You must show your working. Okay, so the volume of that ball is, when it's full, it's 4/3 pi times 15 cubed. So 4, I'm going to ignore the pi, times 15 cubed, divide, and then I've got to divide that by 3, and that's going to be 4,500 pi centimetres cubed. Okay, and it already contains 5,000, so the extra required is of air. Extra air required is 4,500 pi minus 5,000. Okay. And we need to, and then it's that extra air is pumped in at 160 centimetre cubes per second. So the time we need to see how many 160s go into this. Notice I'm not working out this exactly yet because of the pi. I want to keep it accurate until the end. So it's going to be that many seconds. Okay, so I'm going to do 4,500, which is already on the calculator, times pi, take away 5,000, and I've got 9137, etc., etc. I'll write it out, so if you do it in calculator steps, you can see that you're getting it right as you go along. Divided by 160, which is 57 seconds. So yes, it does take less than a minute. To fill the ball up, to fill the ball. Number 10. P is positive, N is negative. For each statement, tick the correct box. P plus N is positive. That is sometimes true. Because if P is a small positive number and N is a large negative number, it's going to be negative. But if P is large and positive, let's do 2 examples. I'll show you why it's sometimes. Suppose you've got P is 100, N is minus 1, P plus N is 99. If you've got P is positive, but P is 1, N is minus 100. P plus N is minus 99, so that's a sometimes. P minus N is positive. Now, if P is positive to start off with, so if we're subtracting a negative number, that's going to be the 2 minuses, make a plus thing. So that one is going to be always true. P squared plus N squared is positive. That's always true, and that's because P squared is positive. And N, if it's negative, but when you square a negative number, it becomes positive. So that's always true. So you get P squared plus N squared. Okay. Now P cubed, if P is positive, P cubed is positive. N, if it's negative, a negative number cubed is always negative. So we've got a positive divided by a negative, which is going to be negative. So that one's never true. Okay. Don't know if there's spaces to put in all these bits here. P plus N. So this is, I'll put the simple one. Let me go back. I know how to do this better now. Let's just put this one here. Move all this stuff over here. So, number 1, it's sometimes. There's an example there. Number 2, that was always true. P, N is negative. So minus N is positive. So P minus N is positive. Don't know how to set this out. If we say N, I think that will do actually. N is negative, minus N is positive. So that's positive and that's positive. Pink for positive. Yeah, so it's positive. Okay, P squared plus N squared. P squared, P squared, P squared. Oh, P squared is positive, greater than 0. A negative number squared. Negative number squared is the negative times itself, which again is positive. P squared is positive, and negative squared is positive. So that's going to be positive when you add them together. And number 4, that was positive. P cubed is positive. P cubed is positive, but N cubed is less than 0, because a negative times a negative times a negative. 2 of them make a positive, but then you get another one negative again, so that's less than 0. So what colour is for N? Just looking at, there's not a colour that begins with N, is there? But anyway. There we are. So I've just, that's positive there, but N is not. N cubed is not. Anyway, let's move on. 250 trains arrived at a station. The number of trains that were late were recorded after every... number of trains that were late was recorded after every 50 trains. The table shows some information about the trains. So in the first 50, there's 16 late. 16 divided by 50 is 0.32. By the time we get to 100, so there's another 5 late, so it's 21. 21 out of 100, 0.21. This one, 36. So the relative frequency is this number divided by this number. So the relative frequency for the next one, 36 divided by 150, 0.24. This one, 38 divided by 200, 0.19. 55 divided by 250. 11 over 50, 0.22. Complete the table, complete the graph. Okay, so here we've got 50, 0.32, 0.12, check the scales, 100, 0.21, 150, 0.24. 200 is 0.19, so we're back down there again. And then 250 is 0.22. Okay. Write down the best estimate of the probability that a train arriving at the station is late. The best estimate, 1 mark. I would say it's the largest one here, because as you get more and more trains, you get more and more close to the probability of a train being late. So 55 out of 250, I would say the best estimate is 0.22. A, B, C have 3 points on a circle. Here, A, B, C. Is the radii from A, B and C are shown here. That's these lines here. Let's put these on so their radiuses. Is AC a diameter? Okay, you must show your work in. Right, if AC is a diameter, then this would be the centre, because all these would meet. All these would meet at the centre, and all these would add up to 360. Is it a bit more? Where's that? Let's just have a little think. I'm not sure about that actually. Now I know where we're going with this one. Yeah, we do need to work out what x is. But what actually happens, if AC is the diameter, then the angle at B there has to be a right angle. Okay? If that angle there is a right angle. Because in a circle, it's one of the circle theorems, the angle, so if you've got a diameter, the angle that you make from going from end to end to the end point of the diameter that you make there should be 90 degrees. Okay, so we've got a bit of angling to work out. Right, so I'm going to start. And remember, these are radiuses. Just going to rub that bit out there. I don't want some of that back. I don't want that bit there. So if these are radiuses, that angle is the same as that one. and this is a radius as well. So it means that that angle is the same as that angle. Right, well, this is, let's see what's going on now. Let's start by doing x plus 5x plus 40 plus 2 times 2x plus 20. So it's x plus 5x plus 40 plus 4x plus 40. So that's going to be 10x plus 80, and that's going to be 360 degrees. So therefore 10x is 360, take away 80 degrees, which is 280 degrees. So x is 28 degrees. Okay, so I'm going to put on some 28s. Put on lots of things. That's going to be a 28 there. This one here, 5 times 28 is 140 plus 40, 180. And then this one is 56, 66, 76 times 2, 76, 140, 152. And this, they all add up to what they should do. 180 around there, 180 there, and 28 and 152. Okay, so I'm going to look in this first triangle here. It's a bit small, I wonder. Let's look at this first triangle here. So what I said before, like, because these, the two blue lines that I've marked there, they're radiuses. So that means that this is an isosceles triangle. So these two angles are the same. So next thing I'm going to do is 180, take away 28, which is 160, 152 degrees. And then we do 152 divided by 2, which is 76 degrees. So that means that these two angles here are 76 degrees. And then we're going to do the same with this other triangle here, because these are also, that's a radius and that's a radius. So it means that this is an isosceles triangle, so these two angles are the same. So next we'll do 180, take away 152 degrees, these are all degrees. That's 28 degrees. Oops, 180, 28 degrees. 28 degrees divided by 2 is 14 degrees. So it means that's 14 degrees. That's 14 degrees. So the angle at B is going to be 76 plus 14, both degrees, 90 degrees. So therefore AC is a diameter. If it wasn't 90 degrees, it wouldn't be a diameter. A straight line has gradient 6 and passes through the point 319. Work out the equation for the line. Right, y equals mx plus c, they're giving us that there. M is the gradient, so y is 6x plus c. And then we substitute x is 3, y is 19, that point there. So we get that 19, 6 times 3 plus c. So 19 is 18 plus c, so therefore c is 1. So we end up with y is equal to 6x plus 1. Okay. The population of butterflies in the park is 4,200. Assume that it increases by 12% each day. Show that after 20 days the population will be greater than 40,000. So day 1 is 4,200. And we multiply. If it increases by 12%, then it's 1.12. That's going to increase. If you multiply by 1, so in 1 day, it'll be multiplied by 1.12. Because we've got 20 days, we've got to multiply it by to the power of 20. Okay, because I'm talking right, 4,200 times 1.12, 1.12, 20 times. So write it, use that notation. 4,200 times 1.12 to the power 20, which is 40. 514 point etc etc, which is great, and that's to the nearest butterfly, and this is greater than 40,000. just going to turn the lights on because it's got a little bit dark in here now. Part B, in fact, the population increases by 13% each day for 19 days, then decreases by 8% for 1 day. Okay, so maybe that's like their lifetime. So then we've got, after 20 days, is the population greater than 40,000? Okay, so it starts off with 4,200 again, and then we multiply it by 1.13 to the power 19. And then to decrease by 8, we multiply by 0.92, because it's 8% is 0.08, so it's 0.92. It's to the power 1, but you don't need to put that on the calculator. So I'll just put that in brackets. If it was 2, we would have to put it in there. So let's have a little look at this then. 4,200 times 1.13 to the power 19 times 0.92. Oh, 39402.8. So it's going to have 39402 butterflies, because we can't have 0.8 of a butterfly. Is it greater? No. Which is less than 40,000. Okay, part C. The expected number of visitors to the park each day depends on the temperature. Less than 21,700, 21 or more, 900 degrees C for in each of the 30 days in June. The probability that the temperature is less than 21 is 0.4. Work out the total on each of the 30 days. Work out the total number of expected visitors to the park in June. Okay. So we're open. So we've got probability that the temperature is less than 21 is 0.4. So we've got 30 times 0.4 times 700 for this one here. Okay. And then the other one, and then it's going to be plus 30. That's a bit messy actually, let's get rid of that. 30 times 0.6 times 900. Okay. So 0.4 of these 30 days is going to be less than 21. So that's 0.4 of the 30 days. It's actually 30 times 0.4. It's actually it's 12 days. Oh, you don't need to write this in. But there's going to be 12 days you're expecting it to be less than 21. So it's going to be 18 days that's going to be greater than 21. Okay, so we've got 12 times 700 plus 18 times 900. 24,600. That's a lot. Right, L is directly proportional to D squared. L is 85 when D is 10. So that means L is a constant times D squared. L is 85 when D is 10, so we substitute that in first of all. That's directly proportional. L, that's on the left-hand side, is directly proportional, means it's a constant times D squared. This here, this information will help us pinpoint the K, and then we can have the general equation. So 85 is K times 10 squared. Substitute these into the right sides there. So therefore K is 85 divided by 10 squared. So it's 85 divided by 100, 0.85. So we've actually got L is 0.85 D squared. Work out the value of L when D is 5. L is 0.85 times 5 squared, 0.85 times 25, which is 21. Okay, 21.25. 16. Here's a cube with edge length x. One diagonal is shown. Circle the length in centimetres of the diagonal. Okay, so this is an X here. So on the base here, that's an X and that's an X because they're cubed. So this is a right angle triangle on the base here. Using Pythagoras, this is going to be the square root of x squared plus x squared. So it's the square root of 2x squared. So the diagonal, that's going to be x squared, Pythagoras. So it's that side squared, x squared, plus this side squared, which is going to be the square root of x squared plus 2x squared. So it's the square root of 3x squared, which is root 3 times x. That one. The total length in centimetres of the edges of the cube is a multiple of 18. Circle the correct statement. So we've got 1, 2, we've got 4 on the top, 4 around the edges, and then 4 on the bottom. So we've got 12x is equal to a constant, a multiple of 18. So x is 18 divided by 12, 1.5 times k. Okay, so it depends what this multiple is. So if k is 1, then x is 1.5. So it's not a whole number. If k is 2, i.e. the multiple of 18 is 36, you have x is equals to 3, so it would be a whole number. So it might be, isn't it? There. Number 17. 20 people were asked which device they use more often, laptop or phone, and here's the results. 1 male, 1 female are chosen at random. Work out the probability. Exactly one of them said laptop. Okay. So we've got 11 males in the survey, 9 females. Okay. Trying to think of a quick way of doing this. So if you've got the male, you've got laptop, phone. If you've got females, you've got laptop and phone. Okay. So we're going to choose one of these males. That's 2 out of 11. That's 9 out of 11. And this is the females. That's 4 out of 9, 5 out of 9. Exactly one of them said laptop. So if you've got a male, oh, two out of 11 there, 9 out of 11 there, 4 out of 9 there, 5 out of 9 there. Okay, so we can say is that if you've got male, we want male, phone, female, laptop, plus female phone, male, laptop. Okay, so male with a phone is 9 out of 11 times female with a laptop, 4 out of 9, and then it's plus female phone, thinking ahead, I put my 99 in before I've got there, and then it's plus female phone, 5/9, times male laptop, 2/11. Okay, so it's 36 plus 10 out of 99, which is 46 out of 99. Okay, the other one, if you've got, I feel like I need to check this one, actually. So what you could also have, if you have male laptop, female, this is the ones that we've ignored. Male laptop, female laptop. And then we've got male phone, female phone. They're the ones that we've ignored. So that's going to be 211 times 49 plus female laptop, male phone, 911, female phone, 59. So that's 8 out of 99 plus 45 out of 99. So it's 53 out of 99. And 53 plus 46 is 99. So that is all the combination. So yes, I'm happy. Okay. Right. 2 males are chosen at random. Work out the probability of the both said phone. So if you've got 9/11s for the first one that said phone times 9/11, so the second one's saying phone, it's 81 out of 121. Okay. Right, I'm just looking through. I'm getting a lift home, so I need to stop right there and I'll carry on soon. Okay.